Hi, everybody. I just want to go through Unit 5, Lesson 4. And this is multiplying and some special cases with binomials. So if you look at my screen, I know it says 9.4, but it's just because it's a slide deck from someplace else. But we are looking at special cases of multiplying binomials. We are going to be using that area or box method. Okay. And so our goal is, can I find the square of a binomial? We'll find out what that means in just a moment. And can I find the difference of squares, right? So squaring means like x squared means x times x, but now it'll be with a binomial. So it'll be the binomial like x plus 3, that quantity squared. For the next one. If you don't want to take the rules and store them in your brain, we can always use FOIL, right? We're not going to use the FOIL method. I can show you that later. Okay. There are certain binomial combinations that occur quite frequently, and they form patterns when they're multiplied. So if you can remember the pattern, it'll avoid you having to use the box method. It's not really necessary. You can always solve these using the box or area method. You don't have to memorize the special case rules. All right, so I'm going to just jump to examples. So here's my first example for you, and it is m plus n, the quantity squared, right? It has no numbers, but that's okay. It's just kind of the general rule. So the first thing you're going to want to do is you know that means you have m plus n times the quantity m plus n, right? Because whenever you square a quantity, that means that times itself. So if you rewrite it out as the two units, then it'll be easier for you to use the area model. It is not just taking the m squared and the n squared because it's the entire quantity. It's the m plus n. So then you can go ahead and use your area or box model, right? And so we do m plus n and m plus n. And then you go ahead and fill in the cells. M times m is m squared. M times n is mn. We do it in alphabetical order. M times M times n is mn. N times n is n squared. If you remember from Friday, we are able to combine like terms. We have m squared plus 2mn because we have two of those mn units plus n squared. Nothing can be combined because they are not all like terms. They are different terms. So we stop at that point and we are done. All right, let's get another example in there. Okay, so we're going to look at this one, which is 3x plus 2y, the quantity squared. And they show you that it's giving you the rule, but we're going to start to see that pattern in just a moment. Okay, so if we go ahead and multiply them, then maybe you'll start seeing that pattern that is above there, which shows you that you take the first unit, it'll be squared, this last unit squared, and in the middle will be the unit, the two units together, multiplied together, and two of them. So I'm going to rewrite. I have 3x plus 2y, and that means 3x plus 2y. So I'm going to use my area model again. 3x plus 2y, 3x plus 2y. And I'm going to go ahead and multiply to fill in my cells. Right, 3x plus 3x, 3 times 3 is 9, x times x is x squared, 2y times 3x, 3 times 2 is 6, and then xy. 3x times 2y, 3 times 2 is 6, x times y is xy, 2y times 2y is 4y squared. And again, just like our previous area models, the diagonal pieces most of the time will be able to be combined. Right, I get my first term, 9x squared. I get my last term, 4y squared. And I have two of those middle terms, right? So x plus x is 12xy. Okay, because you have 6 of each, 6xy and 6xy. That's where this doubling piece comes here. It's saying you take a times y, and you have two of those, right? So our a is 3x, our y is 2y. Those are 6xy, two of those is 12. You do not need to memorize that rule. You just need to know that the unit squared means binomial times binomial, and then you can use your area model. All right, let's see. So here's another one. I'm going to actually go to a subtraction one because I think that's kind of important for you to see the difference. So again, we're going to go ahead and take it's 2r minus s times 2r minus s, right? We're going to go ahead and use that area model again. 2r minus s, 2r minus s. We do our multiplying for the cells. 2r times 2r is 4r squared. 2r times the minus s is minus 2rs in alphabetical order. 2r minus s is minus 2rs, because remember that minus s is like a minus 1s, and negative 1 times 2 is negative 2. The last one, a negative times negative is a positive. S times s is s squared. We're going to go ahead and combine like terms. So we see our diagonal pieces are like terms. So we have 4r squared minus 2rs, and 2rs is minus 4rs plus s squared. You might notice that they follow the same rule as the last one. First unit squared, last unit squared. If you multiply 2r times s, you get minus 2rs. And you have two of those, which means minus 4rs. So it does start to follow that pattern. All right, let's see what we got left. All right, so this one here, I'm going to actually skip this multiple choice question, and I'm going to look at this this last one, right? And so x minus 5, the quantity squared. Some of you are going to start seeing a shortcut, right? So x minus 5 times x minus 5. You're going to use the area model. I'm making it smaller. X minus 5, x minus 5, x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. Negative 5 times negative 5 is a positive 25. And one last time, you can add those two pieces. So you get x squared minus 10x plus 25. Okay? So that should look a little familiar to you. I think we are about done. I'm going to see. I don't want you to go through any more of these. If anything, this is my last case scenario that I'm going to show you here today. And that is when you have the same quantity but the different signs in the middle pieces are actually going to cancel out. So if you notice with this one, 2x plus 3 times 2x minus 3, they use a traditional method for multiplying. I will show you with the area model. So with the area model, if I did 2x plus 3 and 2x minus 3, 2x times 2x is 4x squared. 2x times 3 is 6x. 2x times a negative 3 is negative 6x. Negative 3 times 3 is negative 9. So when you combine these middle terms, you're going to get 4x squared minus 6x plus 6x is 0. They cancel each other out, minus 9. So in this situation, you have your first term squared, last term squared, the middles cancel because these two signs are opposites. Everything else is identical. That is the reason why that's a special case. I'm going to show you one more like that, and then I'll be done with your notes so that this one here, x plus 3 times x minus 3. So again, we can use our box, our area or box method. So x minus 3, x plus 3, x times x is x squared. Negative x times 3 is negative 3x. Positive 3 times x is 3x. And 3 times negative 3 is negative 9. You're going to notice that your middle terms do cancel out, right? Negative 3x plus 3x. So you get x squared minus 9. And again, that's because we notice that we have the binomials are almost identical except different signs, right? So two special cases today. One is when you're taking a binomial squared, you're going to rewrite it as two binomials and then use your normal area or box method. The last scenario is special cases is when you have the same binomial with different terms. Again, you can use the area model and go ahead and solve it like normal, but some of you will start seeing the shortcut that you can cut out that middleman. All right. Thanks, guys. Have a great day.